Engineering hydrology. In this example, we have like a lake with precipitation data, inflow coming to the lake, outflow going out, and evaporation goes back to the atmosphere. So we want to know how we can calculate the evaporation loss in the system. So in this example, the area of our lake is provided. A lake with an area which is provided, and we do know that the bottom and the sides are made from the impervious materials. For the month of June, for about around like 30 days, we have the average inflow coming to the system is which is 5 cubic feet per second, and the average outflow which goes out of the system in 4.5 CFS. The precipitation record for the month of June is 4 inches. And the storage volume decreasing by the amount of 83,000 cubic feet. We want to estimate the evaporation loss in terms of inches in our problem. So let's see how we can approach this problem. So first we need to know the whatever comes to the system is equal to the and the process in the system is equal to a loss or a gain in the height of our reservoir. So delta S, and be careful, all the information in this equation are in terms of inches, in terms of height of water in the reservoir, which is either rise up or moves down. Q in, inflow, minus Q out, outflow, plus the precipitation from the sky, minus evaporation loss, which goes back to the atmosphere, is equal to either a loss or a gain of height of our reservoir. So first of all, our delta S is about the 83,000 feet cubed over the area. And then if you convert it, because we want to have all the information in this equation in terms of inches, so each 12 inches is 1 feet, and it just gives us a numeric value of 0.996 in terms of inches. And because the storage volume is decreasing, definitely delta S is also decreasing, and that's a negative. For Q in minus Q out, we can easily draw our system. 4 inches come from the atmosphere, which is the precipitation. Inflow is provided to be 5 feet cube per second, outflow 4.5 feet cube per second. So the net inflow and outflow is a positive 0.5, and evaporation goes back to the atmosphere, and the volume also decreased in our specific problem. So Q in minus Q out, it just turns to be a half 0.5 feet cube per second. And then if you multiply that for 30 days of June times 24 hours a day times 3600 seconds per day, then divided by the area of the lake, which is 10 million feet square or 10 to 7 feet square, times, and then convert it to inches, it will give you almost 1.5 inches for the result of the Q in minus Q out in terms of inches. Precipitation is provided, delta S, we already calculate this number, and my bad, this number is 0.9. There is a 0 here. And then if the only unknown in our equation is the evaporation loss, and if you just solve the simple equation, it just gives you evaporation is equal to 5.65 in terms of inches. So the closest answer in our multiple choice question is choice D. Thank you. We'll solve more problem in next video in engineering hydrology.